Can we produce sterile lyophilized products using a protective membrane? Welcome to Teclen Lyophilization Knowledge Hub. In this fourth video, we are going to be discussing about the production of sterile freeze-dried products as per the new Annex 1 using protective membranes. Sterile products, as injectables, are bypassing all the natural barriers of the body, what can be very convenient because, as for example, when the product is delivered directly to the bloodstream, its effect is really fast on the patient. Also, we are sure that the molecule is not degraded, as it can happen with the digestive route. But at the same time, injectables can be a major risk if they are including undecided particles, viruses, or bacteria. During the production of freeze-dried products in bioreactors, at the end of the process, the products are sterile filtered, but then they need to be dosed in final packaging and eventually freeze-dried. And these steps can entail a major risk of contamination. The Annex 1 of GMP establishes a legal framework to be able to produce sterile pharmaceuticals without contamination. The preference for fill finish and freeze drying is fully automated systems without human interaction. But what happens with the small batches of biologics and personalized medicine? Is it possible to produce sterile products in hospitals and biotech centers in non-classified areas using a protective membrane? Let's see the following video. We are making use of our pilot freeze dryer. We are loading it with a tray filled with vials, with a stopper in half stopper position. The whole arrangement enclosed in a bag with a protective membrane. We are starting the cycle, and because of the high permeability of the membrane, the cycle develops within the proper parameters. At the end of the process, the vials are fully stoppered in vacuum. So then, can we state that we can produce sterile freeze-dried products using protective membranes? I am going to give you some seconds now. You can pause the video if you want, and then we will discuss about the topic. There is no final answer to this question, as there is a wide variety of applications to consider. But what we can state is that once the product is enclosed at the back with a protective membrane, the risk of contamination is avoided. But this is not sufficient, because the filling and half stoppering step, also the vials introduction inside the bag, should be done in Class A conditions with minimum human interaction. Each project should be reviewed specifically, but let's go to the whiteboard to cover the main points of interest. The first point to consider is the batch size. How many vials we need to load at the freeze dryer. Normal batch size are in between 20,000 2R vials per batch and more than 180,000 vials per batch, what is translated in 5 square meters of usable surface area of the freeze dryer and more than 20 square meters. Here, the preference is fully automatic systems without human interaction. But then, for smaller batches, in between 2,000 or 4,000 2R vials per batch or even lower, what corresponds to 1 square meter or 0.5 square meters freeze dryer, protective membranes can play a crucial role. The second point to consider is the process development of the pharmaceutical to cover by our plant. The development of pharmaceuticals is composed by 4 main steps. Step 1 is the discovery and the development of the active ingredient. Then in step 2, we are testing this active ingredient in vitro in cells and in animals. In step 3, we are testing it in humans. And finally, in step 4, we have the authority review that will approve the pharmaceutical for the final production. The GMP Annex 1 needs to be implemented only from step 3 and forward. But nowadays, there is an increased necessity of hybrid plants that can cover from discovery and development to clinical research. For these hybrid plants, a protective membrane can be of major interest, as the batch sizes during clinical research are smaller than in production. And then the third point to consider: what are the classifications of the room existing in our plant? Class A, Class B, Class C, or even non-classified areas. Because protective membranes combined with other technologies can make technically viable to produce sterile freeze-dried products even in a non-classified area. Freeze drying entails major benefits to produce pharmaceuticals, as it can stabilize complex molecules at room temperature. It also allows to produce sterile. Nevertheless, the process should be reviewed carefully to make it economically and technically viable. From Teclen, we can help providing bags with protective membrane that will assure no contamination of the product during the freeze drying process. If you want to learn more about freeze drying and how Teclen can help you with it, please do not hesitate in contacting us to further review your project.